So we were invited to come talk about probably a term that none of you have ever heard of before tonight, the subniveum, a place that exists at the interface between snow and soil, and a place actually where the vast majority of biodiversity in seasonally snow-covered environments, like most of Wisconsin, persist. I've always really been interested in how organisms make a living in winter. It's a really interesting time to think about biotic interactions, how species interact with one another, how organisms live, in a time that is really a season where everything is scarce.
Yeah, and for my purposes, and where a lot of my interests lie, is in this field of climate change, and in particular with winter ecology and how that's shifting over time. And what we've seen, and it's not a hoax, that over the last 30 to 40 years or so, we've seen some pretty unprecedented changes in both temperature as well as precipitation. And definitely one of the changes we're seeing, or one of the environments that we're most concerned about, is what's referred to as the cryosphere. And so the cryosphere really is this very large expanse of the globe that is either has persistent or permanent snow and ice cover or seasonal snow and ice cover. So in fact, we are right now sort of on the edge of the cryosphere. It extends well up into Canada and the Arctic. And what we've always thought and pretty much considered is that this area, this region, this environment is potentially the most sensitive and the most susceptible to sort of modern climate change.
But really, the vast majority, like I said at the beginning, of biodiversity really occurs underneath the snow. And that's what Ben and I, along with other colleagues, have been more and more interested in, this subniveum space. Most folks, when we look out our kitchen window, we kind of see a blanket of snow, and it has this kind of simplifying effect, and it's beautiful. It makes for this really picturesque backyard, and you can kind of see, everything's smoothed out, it's kind of blanketed over. And I think a lot of us then have this misperception that snow has a simplifying effect on ecosystems and species. But underneath that snow is actually an active ecosystem of organisms. They're not necessarily really big, but they're operating under a really predictable microclimate. So snow has this insulating capacity, like we all know, right? Building a snow cave, making an igloo, something that can keep us warm. Well, it naturally creates these snow caves, small snow caves underneath this subniveum space, where soil is releasing heat. That's causing the snow to melt. That's causing the vapor to rise through the snow column. That vapor condenses and freezes, and it creates a pocket, a small little pocket that probably a lot of us have noticed under big snowpack. And in that pocket, it's really, really stable. Humidity, temperature, there's no wind. It's really predictable and it's really stable. So once you get a couple feet of snow, a foot plus of snow on the ground, this subniveum space develops, it evolves, it grows, and it creates this refugium, a refuge for organisms to utilize. And what's really cool about it is that it is so predictable, and it's actually quite warm. So once that subniveum space underneath the snow forms, it's about 0 degrees Celsius, right? 32 degrees Fahrenheit, just about freezing, maybe just a little bit above freezing, no matter what the temperatures are outside. The number of species that utilize it is vast, it's huge. And the species often that use it have really narrow tolerances on what those conditions can be like. They really depend on those predictable conditions. But with shortening sow season, so the duration, with shortening extent, so it doesn't get as far south as it used to, and with increasing snow density, with climate change, we're seeing a lot of precipitation, but a lot of that, like the month of January, falls as rain rather than snow. That rain falling on snow erodes that subniveum conditions too. So all the consequences of climate change are beginning to alter that subniveum condition, making it more variable, less predictable, and shorter in duration.
You talk about all these things living under the subniveum. What kind of things are you talking about?
So there are a couple of, kind of emblematic species that we can think of. A lot of them have to do with invertebrates or microbes and fungi, but the more exciting ones are things like wood frogs. Wood frogs is a nice example. Wood frogs are, they're a really common frog in upland forests around here, especially those that neighbor ponds. And they go through whole body freezing every winter. So it's a really cool physiological strategy that they've evolved to deal with cold seasons. Their southern range boundary, we're talking about snowshoe hare, their southern range boundary is in Wisconsin. It kind of cuts through the southern edge of Wisconsin. So down by Madison we have wood frogs, but not much further south. Now, wood frogs go through whole body freezing, so that means that as we approach winter, they go into this form of hibernation where they let their whole body freeze. And their heart rate effectively stops. They stop breathing, and they essentially go into a state of suspended animation for the entire winter. But it's costly. It's really energetically costly to come in and out of freezing. And so wood frogs are unable to kind of throughout the season come in and out of whole body freezing. It's costly to freeze, and it's costly to thaw. Costly to freeze, costly to thaw. So eventually they run out of glucose stores, glycogen stores, to be able to make it through winter. And so wood frogs depend on the subniveum. It's predictable. It doesn't freeze-thaw because it's insulated from the ambient conditions. And so too many freeze-thaw cycles, wood frogs die. If it gets too cold, their lower critical temperature, at what point they actually just die because they outstrip their ability to maintain that frozen suspended state, is -8 degrees. So if you fall below that, for example, if there is no snow cover, but then you have a cold snap, you can outstrip their ability to deal with that cold weather. So a wood frog is a really nice example of an organism that really, really is tightly tethered to that subniveum.
And there are a number of other sort of species that I would say are not completely dependent on the subniveum, but use it frequently. So that bird that almost killed me in my younger days, the grouse, will burrow into the snow. They'll create these little sort of snow bowls, and in fact, they'll do this. They can reduce sort of their metabolic costs, like just by kind of maintaining just a little bit warmer temperatures during the winter, and potentially even evade predation that way too. So there are a number of species that kind of use this subniveum environment, both very critically in terms of getting through the winter, but also just throughout the winter in terms of various uses.
So we kind of talked about how we had that warming back in January, and we probably lost about, 6 inches of snow up here. When that snow melts, does that actually crush the subniveum, or does it not affect it?
So what you'll see it from a different mechanism, but the same consequences. Essentially, it will just collapse. And so that really heavy, dense snow, rain on snow events, has ultimately the same outcome.
But it's also important to say about that subniveum can form and basically be lost throughout the course of the winter season. Right. That you can get sort of the snowpack generating and forming, you get sort of the establishment of the subniveum, and then you get something like a warm spell or something like that comes along and you lose that subniveum. So there's definitely this capacity to form and reform and then be lost throughout the course of the winter.